Hey guys, and welcome to Skill-Lync. In today's episode, we are going to take a look at something which is very fundamental to digital electronics. We are going to take a look at the building blocks on which electronic and electrical circuits work. I'm talking about logic gates. Logic gates take multiple inputs and convert it into one output. Just like how the gates at your home allow or block the movement of people, logic gates allow or block the movement of electricity. When electricity passes through the logic gate, the system is activated, and when the logic gate blocks electricity, the system gets disconnected. These two conditions in digital electronics are denoted by the binary digits 1 and 0. 1 for switching the circuit on and 0 for switching it off. Logic gates are tuned to perform basic arithmetic operations to produce the desired output. There are three fundamental operations in logic gates: NOT, AND, and OR. The NOT gate takes a single input and produces an output complementary to the input. If the input is high, the output is low, and vice versa. Just like a day in India corresponds to a night in the United States, a NOT gate inverts what is fed into it and produces the output. If you take a look at this circuit over here behaves like a NOT gate. In this circuit, the switch is the input and the lamp is the output. When the switch is activated, voltage is routed through the circuit that does not involve the lamp, effectively keeping the lamp off. But if the switch is left open, current flows through the peripheral circuit, effectively turning the lamp on. This is exactly how a NOT gate works. When the input is high, the output is low, and vice versa. The outputs of logic gates with respect to the input is usually listed in what is called as a truth table. In this truth table for a NOT gate, you can see that when the input is 0, the output is 1, and when the input is 1, the output is 0. A NOT gate can be used in an electric iron to regulate temperature. When the temperature of the iron exceeds a prescribed value, it can be cut off to prevent heating. The next is the AND gate. The AND gate requires two inputs to produce an output. If both the inputs are high, then the output is also high, but even if one input is low, then the output will also be low. This circuit represents how an AND gate works. This has two switches connected in series to a lamp and a battery. Now, only if both the switches are turned on will the lamp work. Even if one switch is turned off, then the lamp will not glow. In terms of the truth table, you can see the values of the output with respect to the input of A and B. A great analogy of how the AND gate works is the username and password that you use to access accounts. Only if the username and password are right will you get access to it. Another place where AND gates are used are in the seatbelt alarms in your car. Only when you have worn your seatbelt and the engine is switched on will the alarm stay switched off. Next is the OR gate. The OR gate requires at least one high input for the output to be high. Think of it as this. Let's assume that you staying at home is a low output and you going out is a high output. Now it doesn't matter whether you want to go to the beach or the shopping mall. You stepping out is a high output, right? Now if I have two inputs to this, to the OR gate, and A represents going to the mall and B represents going to the beach, irrespective of which one you choose, you stepping out of the house is finalized, and that means your output is high. But if you decide you don't want to go to either places and you want to stay at home, then both your inputs are 0, therefore your output is also going to be 0. Another way of looking at it is having two switches connected in parallel to a lamp and a battery. If either switch A or switch B is turned on, then the lamp will turn on. But if switch A and switch B both are turned off, the lamp will remain off. In terms of the truth table, these are the values of the inputs and these are the values of the output. It doesn't just stop there. You can also combine these gates to get a combination of gates. For example, you can combine the NOT gate and the AND gate to get what's called as the NAND gate. The output of the AND gate is the input to the NOT gate. A NAND gate produces a low output only when both inputs A and B are high. If the AND gate and the NOT gate are placed next to each other, then the inputs of A and B produce an output C, and the input of C, which is fed into the NOT gate, produces an output Z. So if A and B both are high, then output C is also high, which is then fed to the NOT gate, and the output of NOT gate Z is low. NAND gates are used in burglar alarm systems. In burglar alarm systems, the input to the NAND gate are an alarm switch and a light-dependent resistor. An LDR works by allowing electricity to pass through it as long as light falls on it. This completes the circuit, which produces a high output from the AND gate. This is then fed to a NOT gate which inverts the output to keep the alarm switched off. When a thief steps on the sensor, the light falling on the LDR gets cut off. As a result, electricity passing through the LDR also gets cut off. This produces a low output which gets inverted at the NOT gate, producing a high output, thereby triggering off the alarm. The next is the NOR gate. A NOR gate is a combination of the OR gate and the NOT gate. And as long as one of the inputs of the OR gate is 1, the output of the NOT gate is going to be 0. While NOR gates don't have widespread applications of their own, they can be used in combination with other gates. These are just two types of examples that we've given you here. There are various types of logic gate combinations that are possible, like the exclusive OR and the exclusive NOR. Why don't you find out more about these and let us know in the comments? Until then, stay tuned to Skill-Lync.